Hi friends, is my voice is audible to you? If my voice is audible and if everything is fine, please let me know. Right? Okay. Let me have a quick look whether it has got started or not in the online. Okay, okay, okay guys. A very good afternoon to all of you guys. Is my voice is audible? Right, right. Uh, 1 second. Yeah, I think it has got started. So if you people are in online, please say hi so that I will understand. Able to see any sort of comments. If you are in online, please say hi. Okay. Uh, if you are in online, I don't see the comments, brother. Yeah, Vasant Sai. Hi, sir. Hi, Vasant Sai. Right now, I am able to see you people, guys. You people comments. Okay. Right. Thank you. I hope my voice is audible and everything is fine. Yeah. Today's the session is all about the summary of IS 800. So here in this IS 800, I am in, if you take in GATE or in ESE or in any other competitive, there are both working stress method and a limit state method. Both are there. Limit state method mostly I completed like 99 percentage. I completed most of the classes in last month, right? So in this session I will cover most of the concepts of working stress method, that is as per old code of practice, and some of the clauses that I left there in limit state method, those things I cover with the help of questions. That is the major intention behind this summary of IS 800. Okay, there are two concepts are there. If you take any type of competitive examination, working stress method concepts and limit state method concepts. Okay, right. And before I start the session, I just want to convey a very big hi to all of my brothers and sisters who are on the online. Hi Vasant Sai, how are you? And if you people are online, say hi so that I will also understand, right? And before I start the session, I just want to convey there are so much of free content is already happening in this Unacademy learning app. If you are a serious aspirant of GATE or ESE or any other competitive examination, I can recommend you guys to install this Unacademy learning app, because so much of free content you are able to get. One thing, even in terms of video lecture and even in terms of what I can say in the form of PDF notes. Okay. And if you want to follow me in an Academy Learning app, use this link which is given here. If you are able to use this link after installing the Unacademy Learning app, directly you are able to follow me. Right. When you are able to follow me, the advantages, the first and foremost advantage is, uh, the first and foremost advantage that I can say is, whatever may be the free content that I had done in Unacademy Learning app, you are able to access that work. That is first use. Second use, I can say the future coming free video lectures of mine will be notified to you. Second thing, and at the end of each and every session, we provide you in the form, we provide you the notes in the form of PDF for that particular topic. That also you are able to get for free of course. These are the three things generally. These are the three advantages when you are able to follow me. Right. Some people will say like, sir, is there any paid courses there in Unacademy Learning app? Yes, there is a paid course is also there in Unacademy Learning app for full content. So select your goal or target, whatever that may be as GATE and ESE. After you select this your goal and target as GATE and ESE, go to in the main menu, go to, I hope you can say, go to plus courses. After you go to plus courses in the main drop down menu, there is a thing like you are able to see the terminology called as get subscription. When you press on this get subscription, there are two types of courses, paid courses that are visible to you. One is plus course and second one is iconic, right? uh, Iconic, in plus courses there are four advantages are there. Like the first advantage is you have instant doubt resolution is possible in addition to daily live classes and recorded versions. And second advantage in plus course is we will support you with the help of test series so that you can understand at what level you people are in terms of performance. You can compare your performance with the India's top with India's with Unacademy's in an Unacademy's topmost students. That is the second advantage. And coming to the third advantage for this plus, all the courses that are provided by Unacademy are completely structured courses. There is no need to plan yourself, and we will provide the each and every plan. If you stick down to the plan, we are pretty much sure like you are able to get very pretty good rank. And the final advantage for plus is, let us suppose on one day you people may not attend because of your domestic work. In such case, you will be provided with the same access of this live lecture in the form of recorded version. Unlimited access is provided in the form of recorded version. These are the four advantages when you had taken the plus course. In iconic courses, you will have the same advantage just like that of plus, but additionally there are two advantages. You will be given with a separate mentor to clarify your doubts, and you will be given and in iconic course you will be given a special notes to you, special notes for all the concepts. So these are the two advantages for the iconic. So depending on your interest, you can purchase either plus course or iconic course, that is of your interest. But when you had taken any of the course, you will learn from the India's topmost educators. There is no doubt. There is no need to go to Delhi, Bombay, or Kolkata. The topmost faculty of India right now directly available with an academy. So I can say like you will be get taught by India's topmost faculty. There is no doubt at all. Right. And when you want to take this course, if you want to get 10% discount on all the courses, by the time that you had taken this plus course or iconic course, you use this referral code, faculty referral code VT10. It will ask you, do you have any referral code? Then use this referral code VT10. Then directly you are able to get 10% discount on all the courses, like either in plus course or in iconic course in an academy learning app, especially in plus courses. Some people will say, sir, this we are new to this platform. First of all, please introduce yourself. Yes, why not, brother? I am Venkata Tilak Kupalapati. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree also. My major background of education is completely into structural engineering. So here also in an academy, I am going to teach only structural engineering subjects ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction materials and management. All these six topics generally I will take care. Right. Some people will also ask, what is the specialty of this university? Coming to this university has produced six Nobel Prize winners, so you can understand the depth of the research potentiality involved in that university. And moreover, I can say this university ranking is far better than IITs and IIC Bangalore. Brother, I don't have any partiality. So if you refer to the global rankings from the past 100 years, sorry, from any agency, okay, from any agency who give world rankings like Times, anything, okay. So the ranking of this university is far better than IITs and IIC Bangalore, right? And some people and coming to my previous work experience other than teaching, I previously worked as research scientist or research engineer in University of South Carolina for a research funded project. This is completely in USA. For that research project I worked as team leader also, team leader. And previously I worked as head of the department of civil engineering in an engineering college. This is in India. That means I have both local experience and global experience also, you can see clearly. And one more thing I just want to convey you is, being a structural engineer, even till today also I am working as an independent structural design consultant. I personally give structural drawings to my clients and give material testing reports to my clients. This is the brief background. And coming to teaching experience, actually totally I have 12 years of teaching experience. I had mentored more than lakhs of students through online and offline till now. And more than and coming to the this teaching experience, I have to I taught for GATE and ESE from the past 12 years for different coaching institutes all across India. This is my brief background, brother. Right. Let me. Some people will also ask us, sir. You asked us to install this Unacademy learning app, now, sir. How to install that one? Go to Play Store. I hope you people know the smartphone, right? Go to in that smartphone. Go to Play Store or App Store, and you type this name Unacademy learning app. When you type this name Unacademy learning app, you are able to see a logo. In this logo, this type of logo, app will be visible to you. You please install that. When you install that one, you are able to see a screen. You are definitely able to see a screen which is on the right hand side in this way. I hope it is visible to you. So in that screen, uh, you please set, one second, you please set the target. You please set the target as GATE and ESE. After you keep the target as GATE and ESE, I just want to convey you, like in this main drop down menu, if you go to paid course, if you go to paid courses, or I can say Unacademy plus courses, then you are able to see get subscription. When you press on get subscription, if you are able to use this referral code VT10, directly you will be redirected to the payment page. That is how you can purchase the paid course. Some people will come and say like, sir, we are interested to know how we can follow you in this way instead of this link. Yes, I just want to say like, question is how to follow me. If you want to follow me, after you set this target as GATE and ESE, or maybe the other competitive examination, you can go here in this main drop down menu as free courses or free classes or free special classes, something. So after you go to this free classes, then you type my name here in this search button. In the search button, you type my name, Venkata Tilak Palapati. When you type my name Venkata Tilak Uppalapati right now in the search button, and when you press enter, my profile will be visible to you. When my profile is visible to you, you just follow me. These are when you are able to follow me. I already mentioned the advantages, right? This is how you can follow me, brother, right? And another way that you can follow me is after installing the Unacademy link app. Use this link. Then then in such case also you are able to follow me. Right. And the advantages in taking the subscription pitch. These are the advantages. This I had already discussed at the starting stage. These are the four advantages when you had taken the subscription course. Right. These are some of the topmost educators that we have directly, and the courses will be taught separately in English and also in Hindi medium. So there won't be any language barrier also, brother. So whatever may be whatever may be the course, if it is English, the students who are confident in English, good in English, those people can attend English lectures. Those guys who are good in Hindi, they can attend Hindi lectures. There won't be any language barrier. So coming to in GATE and ESC, till now, how many courses were launched? In GATE and ESC, till now, 7 courses were launched. 8 courses were launched. Out of these 8 courses, few courses are in English, few courses are in Hindi. Few courses are long-term courses, few courses are short-term courses. When you had taken subscription, whether you will be paid, you will be given access to all the courses that were launched in your particular stream, in that particular duration, definitely, right? Now coming to the price. So if it is a 12 months duration of subscription, after 10% discount, the cost for plus subscription is 27,225. When if it is a 24-month subscription, the cost after 10% discount is 39,600, brother. So I can recommend this 12 months course for the students who are in the final year, whereas I can recommend this 24 months course to the students who are in third year and second year. This is my recommendation, and you are free to take the duration of subscription from 1 month duration to 24-month duration. Any subscription that that you can take. That is the thing that we can say. Right. Some people will also ask us, sir, okay, right? For any of the course, if you want to get 10% discount, you are bound to use this code VT10. Please don't forget this one, right? Every day, my class in this Let's Crack Gate and ESE Civil YouTube channel is happening. Every day, my class is happening by 11 a.m. Okay, and I can recommend Kamalakar Pandey sir classes also. His class every day is going to happen by 9 a.m. You can even attend Kamalakar Pandey sir classes also. Okay, let us start this session. Before I start the session, I just want to convey, please subscribe to this Let's Crack Gate and ESC YouTube channel. Please don't forget to subscribe to this Let's Crack Gate and ESC YouTube channel, and please press the bell icon. What is the advantage when you press the bell icon? The future coming videos of us in this channel will be notified to you, so that free content you will not miss. And please inform the same thing to your friends, so they will also get benefited, because this is the channel is for free, this YouTube channel. So you can come here and you can ask your doubts, so that we will resolve your doubts, and maybe you can listen to the content that whatever the other faculty is also teaching, and get good rank. That's the motive for this one, right? So, and I just want to convey one more thing. Please raise a thumbs up, so that we can do more free content for you, right? And for your convenience, I already started a Telegram group for you. The name of the Telegram channel is Unacademy underscore Civil Engineer Tilak. If you want to come down to that channel, if you want to resolve your doubts, okay, then you come down to this channel using this link which is given below. Use this link. You are able to redirect to you. You will be redirect to my Telegram channel. Okay. Hi, TikTok Sai. How are you? Hope you are fine. Right. Yes. So can you see this question? Right. I hope you people are able to see this question, brother. Right. So yes, I am expecting answer from you guys, right? So can you see this question? So list the match they had given list one and they had given list two. This is the condition. In which condition we will use which type of I can say we can use which type of welding. That is the question, brother. Is that okay? TikTok Sai, can you answer this question, brother? Can you answer this question? Can you answer this question? Right. So structural members subjected to direct tension or direct compression. In which type of weld the structural members and even what I can say the weld will be subjected to either direct tension or direct compression. In case of butt welds only it is possible. I hope you can say this is one plate in plan. This is another plate in plan. These two plates are kept side by side, and between these two, if I had gone for butt weld and if I am able to apply a load in this way, this weld will be subjected to axial tension, or this weld will be subjected to axial compression depending on the nature. This is how the butt weld can be, right? Isn't it or not? So you can understand directly this option A is suitable for butt weld. So let me show here. This is fifth. So now I can say joining two surfaces approximately at right angles to each other. So when this is a surface, to this surface, if there is another surface is exactly at right angles to each other, maybe I can say in this way. This is one surface, this is second surface, this surface is right angle. So what is the type of weld that is useful there? In this case, the type of weld that is useful there is definitely fillet weld. I hope you know this is how we can go for fillet weld, isn't it or not? So I can say like this B is suitable for fillet weld, isn't it? This type of thing is suitable for fillet weld. Now you can say a hole is made. I hope in this one, hi Vignesh Ram. Yeah, fillet weld. Try to match this one, right? So read the question itself and try to match yourself. Okay, right. Try to match the proper option. A hole is made in one of the components and welding is done around the periphery of the hole. So a hole is done. So I can say a hole is done, and I can say let us suppose this is how a gusset plate is. To this gusset plate, a member is attached. When the effective length of the weld is fillet weld is not sufficient, in such case, generally we will provide a hole or maybe a slot. After we provide this hole or slot, along the periphery of that hole or slot, if we provide the weld, what is the name of that weld? The name of that weld is nothing but it is nothing but slot weld. There is no doubt at all. This is how we can provide slot weld. When we will provide slot welds, if the effective length of the fillet weld is not sufficient, if the lap is not sufficient, in such case we will provide some of the slots. We will take some of the slots. Inside the slots along the along the periphery, we will provide the weld. So this C stands for this slot welding. I can say this stands for one. right? Yes, can you see this pressure is applied continuously, in which case you see the pressure is applied. See, it is not just I can say it is not just electricity, it is we are saying pressure is applied continuously. In which type of weld the pressure is applied continuously, I can say especially this type of weld you didn't see, we didn't use in our in our what I can say in our fabrication sketches. We won't use this type of weld, but generally mechanical engineers use this type of weld. The type of this weld is seam weld. So what is a seam weld, brother? I hope you are able to see the sketch here for seam weld. The seam weld is the process of joining two dissimilar material, two dissimilar similar or dissimilar metals at the seam with the use of electric current and pressure. These are two metal plates. One, this is a two. These two plates can be either similar metals or maybe dissimilar metals. Similar or dissimilar metals are similar or dissimilar plates. So one plate may be of one material, another plate may be of another material. This process is mostly used on metals since they conduct electricity easily and can sustain relatively high pressures here. So this process here, with the help of, I hope these are the roller electrodes. These roller electrodes are rolling over these two plates, which are applying this weld and with pressure. I hope you are able to see this is applying with the help of pressure here. So this type of welding generally we won't see them, especially the mechanical engineers usually use this one. So in such case, the type of weld is nothing but seam weld. Okay. Now, if you see what is the correct option, brother, here, what is the correct code? I hope you are able to see the correct code is option C. A is for fifth one. Na? I hope A is for fifth one. B is for third one, C is for first one, and D is for second one. So the correct option is C. Like that, you need to pick the option. Is that okay, brother? Yes. So C is the correct option, right? Yeah. Can I move to the next question, brother? Dear Vignesh Ram, or maybe Vasant Sai, or any other persons who are seven persons who are on the online. Can I move to the next question, brother? Is that okay? Right. Moving to the next question, brother. Right. I hope you are able to see this. Aluminium is being increasingly used for structural purpose. They are saying aluminium is a material which is used for structural purpose. As a structural element, aluminium is used. In which case structural element aluminium is used. I just want to convey one thing: the properties of aluminium. So based on the properties of aluminium, you can pick the correct option. Is that okay? Hi Dharma Railway, how are you? How are you, brother? Hope you are fine. So this is the question that I had given to you. Please work out the relevant option. Right, right. So I just want to convey. Some people had a doubt like, sir, if aluminium is good in structural purpose, why can't it is using for our regular structure, sir? I can say aluminium things are useful generally in case of aeroplane. I mean, I can say aeronautical structures because of its less weight, because of its less weight and high strength to unit weight. Because when you take unit mass, its strength per unit mass is very high for I can say aluminium when compared to steel, right? So and moreover, this advantage is this one. Another more advantage for this aluminum structures is its maintenance is less. Maintenance is less, right? So its maintenance is less because of these are the two advantages. Now if you know the properties, now I just want to coming to your properties. If you see, they are saying its modulus of elasticity is double that of steel. No, so coming to the Young's modulus of aluminum, coming to the Young's modulus of aluminum, its Young's modulus of aluminum is very less when compared to steel. It is I can write 0.68 times of 10 to the power of 5 megapascal. What is the Young's modulus of steel, brother? It is 2 into 10 to the power of 5. So as the Young's modulus of the material is very, very less, especially for compression members. In case of compression members, the crippling load is pi square EI by LE square. Now when Young's modulus is less, the crippling load for that material is very, very less. So in such case, that element will buckle fastly. So that's the reason why I can say crippling load of aluminum is very, very, very less than crippling load of I can say steel member of same cross section and same dimension, because its Young's modulus is less. That's what you need to understand, right? So it is almost in our words we can say Young's modulus of aluminum is almost, it is when these two, this is 0.68 na, so it's Young's modulus of steel by 3, it's almost one thirds of steel, like that we can say. Now coming this option is wrong. Now coming to the second option, its coefficient of thermal expansion is half of that steel. No, 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 no. Coefficient of thermal expansion of aluminum. What is the coefficient of thermal expansion of aluminum, brother? The coefficient of thermal expansion of aluminum is almost double that of steel, which is almost 23 into 10 to the power of minus 6, 10 to the power of 10 to the power of 23 into 10 to the power of minus 6 per degree C per unit length. This is how we can say. But whereas alpha for steel, it is uh, it is 12 into 10 to the power of minus 6 per degree C per unit length. So it is doubled. So even I can say this is also wrong, right? So this aluminum structures requires less maintenance. Yes, brother Vignesh Ram, it requires less maintenance, no doubt at all. The strength to unit weight, the strength to unit weight ratio of aluminum is high when compared to steel or any other thing. So I can say even this fourth one is also correct. So I can say 3 and 4 are correct. What are the options for 3 and 4, brother Vignesh Ram? Yes. So can you tell me the 3 and 4 options is only option D, na? So you need to pick option D is the correct option. Is that okay? Right, Vignesh Ram? Is that okay, Dharma Railway? Right? So TikTok Sai. Yes. Yes. Right. Okay. So can I move to the next question, brother? Yes, moving to the next question. I hope you are able to see this question, na? Rivets in an eccentrically loaded riveted joint. This is an eccentrically loaded riveted joint. There is no doubt at all. And this is here. This is the CG of the rivet group. If this is 500 kg, here the reaction force will also pass through the CG of the riveted group. No doubt at all. Here, how the moment has got developed. The moment has got developed within the plane of the rivets. That the moment M is equal to P into E. So this is the condition. It is eccentrically loaded, riveted joint or connection. When moment is acting, when moment is acting within the plane of within the plane of rivets, right? When moment is acting within the plane of in the plane of rivets. This is the thing. In this case, generally you tell me what is the which what I can say, which rivet or bolt will be stressed more. I can say which rivet or bolt will be stressed more. Here, because of this moment is just acting just like a, this is a torsional moment here. So because of torsional moment, which type of stresses will develop? Shearing stresses will develop. When you see the torsional stresses, the variation of torsional stresses across the section is more at the extreme, whereas zero at the middle. So here higher shearing stresses are possible at those locations which are at a higher radial distance from the neutral axis or from the CG. So I can say the rule number one is, so the bolts which will experience higher stress is bolts or rivets which are farther from the CG of bolt group. So if you see example, what are the bolts which are farther from the CG of the bolt group? I can say fourth bolt, first bolt, third bolt, and sixth bolt. So everybody will say like, sir, 4, 3, and 6. So some people will say, sir, this is one condition. It is not the final condition. This is one condition. So some people will say, sir, 1, 4, 3, 6. This may be the answer. But there is second condition is also there, brother. Dear fourth and sixth, dear fourth, it's not about fourth and fourth, it's not just about fourth and sixth, brother. One second. I just want to mention even the other things also, right? One second, right? Some people say there is second condition is also there. If you take the resultant stress, resultant force, it is the square root of ratio between axial stress plus Fa plus stress because of bending moment plus 2 Fa Fm into cos theta. So when theta is less, this resultant stress will be more, right? So obviously. So theta is the angle between axial stress and axial stress and the stress because of this torsional moment, right? Now, if you see for fourth element, if you see, this is how the direction of Fa. And direction of Fm will be in this way, perpendicular to the line joining the radial line. So this is Fm. So this is theta here. So coming to the sixth one, this is how. This is Fa. And to this one, this is Fm. This is theta. So coming to third and fourth, some people had a doubt like, sir, this is Fa, okay. And how this Fm can be? This is how the Fm can. Here I can say increased theta. Here, right? Theta is more. So I can say second condition, B condition is if angle theta is less between Fa and Fm, then such bolts or rivets will be stressed more, right? Will be stressed more. So in such case here, if you come down to one, this is direction of Fa. Maybe this is the direction of, not maybe, must be Fm. This is how the angle has got increased in case of 1 and 3. But angle is less in case of 4 and 6. So I can say 4 and 6 are the finalized answers. So 1 and 3 in which the stress developed will be less because of higher angle between Fa and Fm. So I can say 4 and 6 are the final answers, brother. So 4 and 6 are the final answers. So you can pick option D for Detroit is the correct option. So this both condition A and condition B, and both are satisfied, then only I can pick this option, right? So option D. So can I move to the next question, dear Vignesh Ram brother, or Dharma Railway, or any other person who are on the online? Can I move to the next problem or anything, next clause or whatever that you call, right? Moving to the next problem, right? So I hope you are able to see the next question. The cross section of a standard fillet in a triangle. If you take in a triangle, if this is how the fillet is, right? If this is yes, this is yes, maybe this is how actually the side of the fillet will be. But for our approximation, for our easiness, generally this is how we can take it as a triangle type of fillet, okay. Then if this is yes, this is yes, then this is how at what angle, this is how at this angle, this is the throat thickness. But throat thickness is, I can say, s by root 2. This angle made by this throat thickness line with the horizontal is 45, with the vertical is also 45, right? So with the horizontal also it is 45, with the vertical is also 45. So I can pick out of, for a standard thing, this this standard fillet weld, standard fillet weld and is a triangle whose base angles are 45 degrees with the horizontal and 45 degrees with the vertical. So definitely I can pick only option A, right? So first one may be with respect to horizontal, second one is with respect to vertical, right? So you can pick option A. So can I move to the next question, dear Vignesh Ram, or maybe Dharma Railway, or any other person who are on the online? I'm moving to the next question. So I hope you are able to see this question number 42. Right now, this question is actually based on tacking rivets. Now, before I start with tacking rivets, I just want to convey what are tacking rivets are there. What are tack rivets? Tack rivets doesn't carry any sort of load. One thing, these tack rivets are just useful to connect two members as a single unit. but these won't carry any sort of load. Such type of rivets are nothing but tack rivets. For example, if this is a gusset plate here and this is a gusset plate here, between these two gusset plates, there is a member is running, two angle members are running, connected back to back in this way. Example, two angle members has got run connected back to back. Okay, everybody of my brothers or students can directly say, sir, here there are bolts are there. Okay, here there are bolts are there. Now when this element is under compression, you tell me there are how many angles are there, brother? Here there are two Indian standard angles, I can say, which are connected back to back, right? Connected back to back. In order to keep these two elements together, because of this compression, when these two elements are not acting together throughout the length, in such case the load carrying capacity of these members will get decreased. In order to act these two members to act as in unison, to make all members to act in unison along the length, I can say definitely the stack rivets are useful. These are tack rivets here, here, here. So this is nothing but the spacing of tack rivets or pitch of tack rivets, I can say. This is pitch of tack rivets. So pitch for tack rivets are different, whereas pitch for black bolts or ordinary bolts exactly at the joint or connection is different, right? So can you people tell me, sir, what is the tacking rivets, brother? So the tacking rivets in compression plates not exposed to the weather, having a pitch not exceeding 300 millimeter, or in case of when it is not exposed to weather, in such case the pitch of tack rivets, I can say, pitch of tack rivets shall not be shall not be more than 32 times of thickness of the plate, or it should not be more than 300 millimeter when the stacking rivets are not exposed to weather. So I can say option is C, no doubt at all. But some people will say like, sir, is there any clause is there, especially here, uh, this is for plates, like when tacking rivets are attached in compression, these are for plates. Some people will come and say like, sir, this is the class for compression plates. Now instead of plates, if I use any other, if I use any other member like angles, or like maybe channel sections, anything. In case of angles or channel sections, the maximum pitch of tack rivets, the tack rivets maximum pitch should not be more than 1000 millimeter. In case of tension members, should not be more than 600 millimeter in case of compression members. So some people had a doubt like, sir, why there is a two different clauses? This is for plates, brother. There is a lot of difference between the cross section shape of plate, the cross section shape of angle and channel. So for plates, this is how we can take, whereas for angles and channels we can take in this way. That is how you can see, brother, right? So we can say option C is the final option, right? Some people will also ask us, sir, you are saying this is the thing when plates are not exposed to weather. Let us suppose, sir, when plates are exposed to the weather, in such case, definitely I can say the spacing of the stacking rivets will has got changed, na? Yes, definitely, brother. So let me write that clause also. In this case, the answer is C. There is no doubt at all. Well, let me write even that clause. When plates when plates are exposed to weather, in such case, maximum pitch of tacking rivets should not be more than, here in such case it is 16 times of T, and it should not be more than 200 millimeter. This is the case when it is exposed to weather. When the plates are exposed to weather, in such case the maximum pitch for tacking rivets or tack bolts I can take. So when plates are not exposed to, this is the condition of not exposed. When the plates are not exposed to weather, in such case, aggressive environmental agents will not act. In such case, the maximum pitch can be increased. Maximum pitch of tacking rivets. These are the clauses for tacking rivets. Please understand, these are not the normal pitch clauses. These are the clauses for tacking pitch for tacking rivets or tacking bolts. So maximum pitch for tacking rivets or tacking bolts should not be more than here it is 32 times of T and should not be more than 300 milliliters. Right? For this one, it is not exposed. No? Directly, I can keep this one. Is that okay, dear Vignesh Ram? Is that okay, Salu Salima? Is that okay? Right? Why there is a higher maximum pitch for tacking rivets? Because here in this case, it is not exposed to weather. When it is not exposed to weather, environmental aggressive agents will act less. Durability problems are less. Less durability issues. Here I can, when exposed to weather, I can say more durability issues. Can I write that one? More durability issues from environmental conditions, right? So can I move to the next question? Is that okay? Moving to the next question. Salu Salima, Vignesh Ram, okay, Dharma Railway, any other person who are on the online. Moving to the next question. I hope you are able to see the next question. Tacking rivets in tension members are provided in pitch in line, not exceeding. So in case of tension members, I can say what is the maximum pitch of tacking rivets? I already mentioned maximum pitch of tacking rivets for tension members. I already mentioned in your previous class for tension members should not be more than 1000 millimeter. For compression members, maximum pitch of tacking rivets should not be more than 600 millimeter, as they are expecting for tension members na. So that's the reason why I can go for 1000 millimeter. So it is all indirectly always called as 100 centimeter, right? So I can go for D for Detroit is the correct option. Is that okay, Vignesh Ram? Salu Salima, right? So can I move to the next question? Right, moving to the next question. So I hope you are able to see, you guys are able to see this next question. The effective section of fillet weld is represented by a triangle ABC whose sides S1, S2, S1, S2 and S3 are such that this S3, this dimension is more. Next dimension more is this S2. The least one is S1. If the allowable shear stress in the weld is tau, okay, the resistance of the weld per unit length. So how you can say the resistance of the weld or strength of weld generally, strength of total weld generally it is the allowable shearing stress, which is tau multiplied by effective length multiplied by, I can say, throat thickness. What is the throat thickness here that was given in the problem? In the problem, the throat thickness is the least effective thickness of the weld, along which the crack will originate, which will be the least thickness. So in case of any weld, the least thickness will be the throat thickness. What is the least thickness here? The S4 is the least thickness. So S4. Yeah, they are expecting the resistance of the weld per unit length. For total length of LE, it is much. This much. What is the strength of weld per unit length, brother? Per unit length, it is tau into S4. I can write divide by SE because I want to get per unit length. Now, so I need to write the above formula divided by LE. So in such case, I will end up with tau into S4. So directly I can pick option D for Detroit is the correct option. Is that okay, Vignesh Ram? Salu Salima, is that okay? Can I move to, I mean, Dharma Railway or any other person, Vasan Sai, is that okay? Can I move to the next question? Right? Some people had a doubt like, sir, in case of working stress method, what is this tau? The working stress method, the tau value is 108 megapascal Newton per millimeter square. In case of working stress method, the tau value, the allowable shearing stress, the tau value as per limit state method, which is design shearing stress, which is Fu by root 3. It is the actual shear failure divided by factor of safety. Maybe one factor of safety gamma m, maybe 1.25 for maybe 1.25 for shop welding, 1.5 for site welding. So I can say this here gamma m is 1.5, 1.25. This is in terms of limit state method. This is in terms of working stress method. In terms of working stress method, both for shop weld and site weld, the answer is 108 megapascal directly. So can I move to the next class? Is that okay? Vignesh Rambro. Moving to the next class. I hope you are able to see the next question. The steel parts at right angles are welded with a steel parts at right angles. Maybe this is a plate, maybe another plate. Okay. These steel parts at right angles are provided with a fillet weld of, are connected with a fillet weld of 10 mm size of fillet weld. They are taking this as 10 mm size fillet weld. Okay. So the angle between the two fusion surfaces is 90 degrees. And the angle between the two fusion surfaces is 90 degrees. And the throat thickness, how we can take the throat thickness, brother? So when the angle between the fusion surface, this is fusion surface 1, this is fusion surface 2. The angle between the fusion surfaces are between 60 degrees less than or equal to theta less than or equal to 90 degrees. In such case, throat thickness is generally I can write S by root 2, which is 0.707 times of S. So in such case, it is 0.707 times of size of weld is 10. So it is 7.07 millimeters. So I can say it is 7 millimeters. The final option I can make it as option A. But when the angle of what is the another conclusion that we can say, when the angle of fusion faces and the angle between fusion faces increases, right? Then the thickness of the thickness of fillet weld decrease. So this is the another rule generally we can say. So the option is A for Amsterdam is the correct option. So can I move to the next question? Going to the next question. Right. I hope you are able to see which one of the following statement regarding the riveted connection shown in the figure is correct. They are saying out of four things A, B, C, and D. Out of these four, which one is correct? Right. So they are talking about. I hope you are able to see. This is in elastic theory. All rivets carry equal forces. In plastic theory, all rivets carry equal forces. Both in elastic and plastic theories, all rivets carry equal forces. I just want to mention you in the at the times of assumption of analysis and design of this riveted connection in elastic analysis. In elastic analysis, at the starting stage, they mention like each and every rivet or bolt will carry equal will carry equal force. That is the first and foremost assumption. I am saying that is the assumption in case of elastic theory is there. So in elastic analysis, I can say each and every bolt or rivet will carry or share equal load. Now coming to sir, in case of some people think like sir A is correct. Now maybe there is a chance like B is also correct. When A and B are correct, then C should be the correct one. Na? So let us think about plastic theory. So what will happen in case of plastic theory, brother? In plastic theory, I hope you guys know about plastic theory. I had detailedly done like 11 hours of session on plastic analysis. So you go and watch that 11 to 12 hours of session, especially on plastic theory. So if I go to in plastic theory or in plastic analysis, in plastic theory, what is the thing that you can say when in plastic theory, when load is increased, the more highly stressed rivets, like the more highly stressed rivets, which are starts yielding earlier, the more highly stressed rivets. The more high, what are the more highly stressed rivets? The rivets which are nearer to the applied load. The rivets which are nearer to the applied loads are A and D. the more highly stressed rivets starts yielding earlier. Okay, when it starts yielding earlier, there is no problem. And when it has got, when A and B has got start, when A and B has got started yielding, then after that one, when they are started yielding, then redistribution of stresses will happen, right? And there I can say, and there and there and there is redistribution of load. I cannot talk here in terms of, because this, the application is in terms of load na? And there is redistribution of load among rivets. The failure will occur. The failure will occur when all the rivets had yielded. Failure will occur when all the rivets when all the rivets have yielded, and the strength of the group of the rivets, and the strength of the rivet group is equal to strength of one rivet, a rivet value into number of rivets. So that means each and every rivet will carry at max its strength, which is nothing but strength of the rivet. Here also in plastic theory. That means option A and option B both are correct. So I can say the correct option I can go with C. So both in elastic and plastic theories, all the rivets carry equal forces. That's how we can say. Sir, plastic analysis videos where, sir? Dear Vignesh Ram, maybe I can say before 2 months in the same here I can say uh, in the same YouTube session. Okay, in the same YouTube session, you go and type here in the same YouTube session, plastic analysis by Venkata Tilak sir. So I can say I had done like 6 parts on plastic analysis or plastic theory. So you will get all those 6 parts. Maybe the duration may be 11 hours or 12 hours or maybe 10 to 12 hours it may be. So you will get all those things. So go through that one. Definitely a 2 mark question is mandatory from plastic analysis. So that's the reason why I had done that. So it is there in the YouTube, brother. Maybe if you refer before 2 months, I think maybe 2 months or 3 months, I had done this one. Okay, is that okay, Vignesh Ram, brother? Okay, it was there only. Okay, I mean the same channel, like let's crack GATE and ESE civil YouTube channel. Is that okay? You go and refer that in the same channel. Okay, yeah, right. Thank you. Okay, moving to the next question. So maybe in this question, select the correct statement. So there is a some select the correct statement. So what is the correct statement out of this one? Select the correct statement. What is the correct statement here? Maybe I can say material cost of a rivet is higher than that of a bolt. So when compared to bolt, material cost of rivets are high. You cannot say like that directly. So here in case of rivets, you cannot directly mention this way. You cannot justify this one. So this may be wrong. Not maybe, this must and should be wrong. So it depends. It depends on the cost of the labor. It depends. So you cannot directly mention. And tensile strength of the bolt is lesser than that of rivet. And tensile strength of the bolt, they are saying like tensile strength of the bolt is lesser than that of rivet. So they didn't mention like the diameter will be same or constant, diameter will be different. They didn't mention. So if there are two different diameter, if the bolt is having higher diameter, if the rivet is having lesser diameter, so tensile strength of the bolt will be higher. So even you cannot say this cannot be correct, right? This is correct when the diameters of the bolt and rivets are same, but there is no condition was mentioned like diameters of the bolt and rivet are same. In such condition, this is like that. So I cannot even go for that one. Now coming to the next one, bolts are used as temporary fastening, whereas rivets are used for permanent fastening. Yes, This is correct. We generally go for bolted connections because whenever if I want to remove the erection, if I want to dismantle the erection, then in such case generally I will go for this bolted connections. Whereas if I want to go for as a permanent structure, generally I will go for riveted connection. Right. So this is definitely this is the correct one. Right. Riveting is less noisy than bolting. No, in case of riveting, more noise will come. More noise will come from riveting action, because in case of riveting I need to, if I had gone for a rivet in this way, even from the bottom with the help of a die, I need to keep from the bottom also, its shape should also come in this way of snap head. In such case I need a hammer and I need a die, I need to heat it continuously when it is hot driven. So in such case more noise will come. So this option D is also wrong. It is not less noisy, it is more noisy. So the correct option is only option C, right? So can I move to the next question? Right. Moving to the next question. When bolts are subjected to reversal of stresses, I hope you know. When the bolts are subjected to reversal of stresses, reversal of stresses, the most suitable type of bolt. What is the bolt which will take care of this reversal of stresses? What do you mean by reversal of stress? So when the bolt, if you take a bolt, when the bolt is subjected to dynamic action because of moving loads or earthquake loads or maybe anything, the bolt will get vibrate to the left hand side and right hand side. So in such case, this is the phase. This phase will be under compression right now. When it has got bent in this way, the same phase is under tension. So on the same phase of the material, if alternative tensile stresses and compressive stresses, if the nature of stresses are changing, such in such case, such type of stresses are nothing but reversal of stresses. This reversal of stresses directly coming to picture due to dynamic loading action and maybe earthquake or maybe wind actions, etc. In such case, which type of bolts are better? What are black bolts, man? Black bolts are nothing but ordinary bolts or common bolts, ordinary unfinished bolts. So the same thing. These both are same. Turned and fitted bolt. No. The high strength frictional grip bolt is the correct option. In case of high strength frictional grip bolts, HSFG bolts, what is going to get happen in case of high strength frictional grip bolts? The resistance to external loads. High strength frictional grip bolts connection. The resistance to external loads. Resistance to external load will be by the action of frictional grip between the plates, between the plates. How the frictional grip between the plates will come? Due to heavy compressive action applied by HSFG bolts on plates. Because of heavy compressive force action applied by HSFG bolts on plates, if this is how this is how the connection is. So this is the HSFG bolt. If with the help of with a heavy compression force, if I had proof loaded this HSFG bolt, if I had tightened this, if I had tightly tightened this HSFG bolt with the help of a wrench, right? So in such case, after tightening, these two plates were applying over these two plates, heavy compressive force was got applied. I hope you can say some clamping force type of stuff, some clamping force type of stuff has got applied. So when some clamping force type of stuff has got applied here in between these two plates, definitely, right? So because this will be just like a normal reaction, and because of friction between these two plates, so the external loads that is coming into picture because of dynamic action, the dynamic action load is resisted by the frictional force here, frictional force here. That frictional force is coming into picture due to heavy compression action applied by high strength frictional grip bolts on plates. So on counteraction, these plates will apply a high tensile force on the bolts. So both are equal and opposite. So on these bolts are under axial tension. HSFG bolts are under axial tension, whereas plates are under compression. Right, so you can say option D itself is the correct option. Is that okay, dear Vignesh Ram brother? Right? Salu Salima. So can I move to the next slide? Right. So can you see this question? A bolt is subjected to shear force. A bolt is subjected to shear force V and tension force T. A bolt is subjected to shear force V and tension. V is the shear force, developing shear force, and T is the developing tension force. Right? The capacity of the bolts in resisting shear and tension. So shear strength is V naught is shear strength, and T naught is tensile strength. Which one of the following? Which one of the following diagram represents the interaction relation as per IS 800 2007? It is with respect to limit state method. So with respect to limit state method, if you see the interaction equation, the developing shear force, maximum developing shear force by shear strength of the bolt square plus maximum developing tension force by tensile strength of the bolt square. This should value should be less than or equal to 1. This is the interaction equation that the bolts or the rivets should follow when the bolts are subjected to both shear force and tensile force. This is the interaction equation. This is the condition that needs to be satisfied. Condition that needs to be satisfied when bolt or rivet are subjected to axial tension and here axial tension and shear, right? So definitely I can say out of now, dear Vignesh Ram, you tell me, out of these, this is as per limit state method. If I just want to convey as per working stress method, in working stress method as per old code of practice. So if this is the answer, this is following, this is square. This is square. When it is square, what is the type of shape of the curve between V by V naught and T by T naught will be? These are squared, na? So these are squared means V by V naught and T by T naught is a square means this is a parabolic way of relation, right? Parabolic relation. So directly you can pick option B itself is correct because it is the variation is just like that of a parabola, and the limit maximum limit is 1. So when v by v naught is 1, t by t naught is 0, right? So here when I go to this one, v by v naught is 1 and t by t naught is 0. When t by t naught is 1, v by v naught is 0, and the variation between these limits 1 and 1 is just like that of a parabola. This is the answer as per limit state method. Okay, so answer is B, no doubt. Now I just want to give one more thing as per old code. I mean, I can say IS 800 1984 code. If you go to old code, which is based on working stress method, if it is based on working stress method, the same interaction equation was given in terms of stresses. And in such case, the interaction equation or the condition that was given is developing shearing stress is Q and the shear strength of the material is Q naught. Q by Q naught plus tension force, tensile strength is F. F by F naught, this value should be less than or equal to 1.4. What is Q? It is developing stress, developing shear stress. What is Q naught? I can say Q naught is, I can say shear strength. I can say shear strength of bolt or rivet. What is F? F I can say with the help of a single line. F is the tensile stress. I can say I'm developing tensile stress. F naught. Tensile strength of the bolt or rivet. Tensile strength of bolt or rivet. This value, this value of this combination should be less than or equal to 1. Is how we can say. So when it is less than or equal to 1.4, this is for as per new code. What is the answer as per old code, brother? The answer as per old code, this should be less than or equal to 1.4. So when q by q naught, when v by v naught, or I can say when q by q naught. So in such case, here instead of v by v naught, they should give q by q naught. Here instead of t by d naught, they should give f by f naught. This is how we can pick the correct option in case of old code of practice. Right? In case of old code of practice, I can pick option D for Detroit is the correct option. But they are clearly mentioning as per new code of practice. In new code of practice, the same thing they are giving with respect to forces. Whereas in old code of practice, the same stuff they had given as if as a straight line relation, and the relation value maximum limiting value is 1.4. I can say this is how I can say the difference between old code and new code for the same class, right? Can I move to the next question, brother? Is that okay? So can I move to the next question, brother? Right? Navjot Singh. Yes. Yes, linear as per old code. Yes, linear as per old code. Because there is a chance, like there is a concept of working stress method and limit state method. Working stress concepts are completely as per old code of practice. Limit state concepts are completely as per new code of practice. So if you see in any competitive examination, working stress concepts are also asking, limit state concepts are also asking. But for GATE, most of the concepts, like 99%, the concept will be asked in limit state method. But for JE examinations, maybe SSC JE, RRB JE, then in such case, working stress concepts are also required. So in such case, you need to understand the difference. Okay? Vignesh Ram, is that okay, brother? Now those things do by. I say, oh, brother, good, good, brother. So can I move to the next question, brother? Okay? Yeah. Moving to the next question. I hope my brother Navjot brother can see this one. Salu Salima also can see this question. The actual thickness of butt weld as compared to the thickness of the plate. So I hope you know butt weld. Where you will keep the butt weld when two plates are kept side by side. This is one plate, maybe. This is another plate, maybe I can say. These two plates are kept side by side. Now, if I had gone for butt welding, how I had gone for butt welding, this is how I can go for butt welding. The size of the butt weld generally we will provide. These are nothing but reinforcement. The extra thickness of the weld, which is more than the size of the weld, which is more than the thickness of the plate. That these are nothing but reinforcement. Generally, the reinforcement generally will keep is 1.5 millimeter to 3 millimeter thick. Reinforcement generally will provide thick reinforcement. Now you tell me, so when compared to the thickness of the plates, the size, what is the size of the butt weld? I can say clearly say this is the size of the butt weld, right? The size of the butt weld is higher or lesser. The higher it is, definitely it is more. Sense like it is more. They are not talking about the throat thickness, or they are not talking about the throat thickness of the butt weld, effective thickness of the butt weld. They are talking about the actual thickness of the butt weld. The actual thickness of the butt weld is more, but whereas the effective thickness of the butt weld in the case of sickle butt weld is the effective thickness. If I want to talk about effective thickness of butt weld is 5 by 8 times of thickness of thinner plate. This is the case in case of single butt weld. In case of double butt weld, if there is no data is there, the effective thickness of what is the effective thickness of butt weld in case of double butt weld. Double butt weld means single butt weld example is single U, single V type of butt weld. This come under single butt weld. Double butt weld. Double U, maybe the shape is in this way. Double V, the shape may be in this way. Double U, double V shape. This type of double butt welds. In case of double butt welds, the penetration of weld is more. In such case, in the absence of data, I am saying in the absence of data, the code asked us to take this one, which is 1 times of thickness of thinner plate. Thickness of thinner plate. But here they are asking about actual thickness. There is a lot of difference between actual thickness and effective thickness. And when it is actual thickness, it is more. When it is effective thickness, in case of single butt weld, it is less. Like that, you need to pick the option. Okay, option is A. Is that okay? Yeah. Can I move to the next question? Is that okay, brother? Moving to the next question. So I hope you are able to see this question now. Right, brother? Consider the riveted joint shown in figure. If there is a riveted joint which is shown figure, the minimum permissible value. What is the minimum value of this? P stands for pitch, because pitch is the distance between two adjacent rivets or bolts in the direction of applied loading. So in the direction of applied loading, the distance between two adjacent bolts, that is nothing but pitch, right? So this is, they are talking about the minimum pitch. In case of what is the nature of this system of forces, the force system is, it's a tensile system of force, because these are tensile forces. Now what is the minimum permissible value of pitch? Minimum pitch value. What is the minimum pitch value in case of tension members or compression members? It is 2.5 times of, if you refer to the code of practice, it is the minimum value is 2.5 times of diameter of the bolt or the rivet. I can say nominal diameter of rivet or bolt. So in such case, it is 2.5 times of, what is the rivet diameter, brother? Nominal diameter of the rivet is 20 millimeter. So 2.5 into 20, so it is around 50 millimeter. So I can say the option is directly 50 millimeter. Sir, in IS 800 2007, rivet is not told. Yes, Navjot Singh Sidhu, in IS 800 2007, rivet is not told. This is the case. They had, instead of saying this as a rivet, they mentioned that as their terminology called as fasteners, dear brother. Dear Navjot Singh Sidhu, they used a terminology called as fastener. What are fasteners? A fastener can be bolt, or the fastener can be rivet. What is the fastener? With the help of which type of connection you are making a joint, that is nothing but a fastener. Maybe a bolt, rivet, or maybe the fastener can be even weld also. So when the fastener is by bolt or rivet directly, you can directly use it as 2.5 times of 20 millimeter. Is that okay? Right? So can I move to the next question, brother Navjot Singh Sidhu? Vignesh Ram, brother. Moving to the next question. I hope you are able to, please subscribe to our channel. Please share this video. Please like this video, brother. Because with so much of pain and for free of cost, we are doing this one. Na? Please inform the same thing to your friends so that they will also get benefited, na, brother. So you are doing some good thing at least to your friends also. So please inform the same thing to your friends so that they will also get benefited, right? Yeah. So moving to the next question, brother. Oh, ouch. So moving to the next question. Yeah. I hope if a bolt of nominal diameter 18 millimeter, then gross diameter of the standard clearance hole as per IS 800 2007. Bolt of diameter 18 millimeter. So this is not a rivet. Please understand, this is as per IS 800 2007. So this is for bolts, not for rivets. The clearance value for bolts is different, for rivets are different. If it is in case of bolts, if the nominal diameter of the bolt is between 12 millimeter till 14 millimeter, then this gross dia is nominal diameter plus 1 millimeter. This 1 millimeter is the clearance in such case. When the diameter of the bolt is between 16 to 24 millimeter. In such case, the clearance is 2 millimeters is the clearance value, brother. Right? So when here when the diameter of the bolt is more than 24 millimeter, in such case the gross diameter is phi plus 3 millimeter. These are the clauses as per IS 800 2006 2007. The clauses, the clearances are different for rivets. Okay, this is directly it was given as bolt. In such case, our diameter of the bolt is 18 millimeter, is between 16 and 24, isn't it or not? Is between 16 and 24. In such case, what is the standard clearance hole? What is the standard clearance hole? Gross diameter or standard clearance hole diameter? What is the whole diameter, brother? It is phi plus 2. In such case, phi is 18 plus 2. So in such case, it is 20 millimeter, right? So you can directly pick this option is B for Boston is the correct option, right? Dear Navjot Singh Sidhu, it is you don't think that one. Go and refer this one. You are saying, dear Navjot Singh Sidhu, let me tell you. Your case is, this is for bolts. For bolts, this is this one. For rivets, brother, for rivets, when the diameter is less than or equal to 25 millimeter, in such case gross dia is phi plus 1.5 millimeter, brother. Go and refer that one. It's not if you want to refer these clauses, you go to IS 800 2007 section 10. Go and refer in section 10 connections. This tabular form was there directly in the first page of section 10. The first page of section 10, you can say, in the first page of section 10. I just want to convey where our brother Navjot Singh Sidhu has got a difference. That is for rivets. In rivets, this is given directly, this clause is given in working stress method. This is as per IS 800 maybe 1984 code, brother, right? When this fee is more than 25 millimeter, in such case it is fee plus 2 millimeter is the clearance, right? This is the difference. That's how the clearance, standard clearance values are differing from old code of practice and new code of practice. Those are different, brother. Okay, right. So can I move to the next question, brother? Right? Yeah. So moving to the next question. So I hope you are able to see this question. In which of the following cases is a structural fastener is over designed? Fastener means, don't, fastener means it's a bolt or rivet or weld, anything. It's a fastener which is able to use to connect two or more elements together. So in which of the following cases is a structural fastener is over designed? In which case the structural fastener, in which condition the structural fastener is over designed? When design is based on Unwin's formula. Dear, Unwin's formula will only give a relationship between the thickness of the plate and the nominal diameter of the bolt. Nominal diameter of the bolt that you need to use is 6.01 times of root t. This is only Unwin's formula. Unwin's formula doesn't talk about whether the whether the bolt should be over designed or under designed. It won't convey anything. So this is the wrong answer. Only Unwin's formula will give a relationship between the nominal diameter of the bolt or rivet and the thickness of the plate, whatever maybe that we are using, right? Yes. And long sustained loading due to creep. In every case, in every practical case, long sustained creep loading is there. No, this is also not the thing, right? Even this is also not the correct option, I can say. If you take, I can say, when reversal of stresses are happening, when this reversal of stresses will happening due to dynamic loads. When due to dynamic loads are acting, in such case the structural fasteners like bolts and rivets are asked to over design. Yes, in case of dynamic loads like earthquake loads and wind loads, the structural fasteners are will be designed for higher over design. In case of fatigue loads also, repetitive type of stresses are coming into picture in case of this fatigue loading. So due to fatigue loading, repetitive stresses will come into picture. Yes, in case of repetitive type of stresses are coming into picture, in such case I have some problem in plate gutter. Dear brother, if you had any problem in plate gutter, you are free to ask. The last 5 to 10 minutes, I will give you doubt session. In the doubt session, you can ask your questions in the plate gutter. Dear Navjot Singh brother, is that okay? You are free to ask the doubts in the last 5 to 10 minutes. I will provide you, so you can ask that one. It's not at all a problem. We are here to resolve your doubts only, na. Don't worry, brother. We are free. I mean, we are free in sense we are here to serve you. Okay, why we are doing all these things? To serve you only, na, to get good name, good fame, right? So that's the reason we are doing, right? Yeah, don't worry. We will help you. Don't worry. Last 10 minutes I will spend to you, and you can ask me the doubt in that in any topic of steel. We will solve your doubts. It's not at all a problem, right? So I can say that third and fourth are correct, na. So I can say like option C is the correct option for this, right? Can I move to the next question, brother? Navjot Singh Sidhu. Yeah, Vasant Sai, right? And Vignesh Ram, Salu Salima, other persons who are on the online Dharma Railway or any other person. Okay, those persons who are entirely on the online. Can I move to the next question? Yes, moving to the next question. I hope you are able to see this next question. Na? A 20 millimeter. This is a directly question. So this type of question you can expect for 2 mark questions. 2 mark questions in gate, or maybe in gate you can get this one. So this type of 2 mark question you can get. A 20 millimeter diameter. See, understand, these are rivets. So please understand, these are for rivets. Okay. So rivets are used to connect 10 thick plates. So to connect to 10 thick plates, to connect 10 thick plates, we are using a 20 diameter rivets. Okay, 20 diameter. The nominal diameter is 20 millimeter. So what is the gross diameter of the rivet, or what is the diameter of the rivet after riveting process? The diameter of the rivet after riveting process is nominal diameter plus 1.5. In this case, 20 plus 1.5, it is 21.5 millimeter. Is that okay? This is gross diameter of the rivet after riveting process. Diameter of the rivet after riveting process. Its diameter will get increased, which is equal to diameter of hole, definitely, right? Now the permissible stresses for rivets in shear and bearing. The permissible stress in shear, so tau is 80 megapascal. Tau permissible 80 megapascal. And bearing stress sigma, permissible bearing stress is 250 megapascal. These are the options for field driven. These are the options for hand driven rivets. There are permissible stresses in case of hand rivet. They are asking a difference of rivet value in single shear and double shear. What is the difference in rivet value? So in case of single shear, when it is in single shear, what is the rivet value? What is the rivet value in single shear, brother? What are the diameter of the plates that we are using, brother? Diameter of the plates that we are using are 10 millimeter, and this is also 10 millimeter. Okay, in single shear, I can say I need to consider the minimum of two things. One is the shear strength, and second one is bearing strength. Coming to the shear strength, how we can write the shear strength? Permissible shear stress. Permissible shear stress is 80 into shearing stress. The shearing stress is acting in case of single shear on the cross sectional area of single rivet. What is the cross sectional area of single rivet after riveting process? The cross sectional area of single rivet after riveting process, pi by 4 into d square. D is 21.5 square. If you work out, this value is 29.04 kilonewton. You will get this answer in terms of Newton. But after I work out this answer, uh, yeah, sir, which book should I refer? Using SS Bhabikati. Dear brother, Navjot Singh Sidhu, SS Bhabikati is sufficient to know how to tackle the problems. If you want to learn more about reasoning, like reasoning, right? If you want to improve your knowledge, you need to go and refer the code of practice first. But in code of practice, if you want to get the reasoning for the code of practice, the reasoning for the code of practice is mostly given in Subramanya textbook. I hope you know Design of Steel Structures by Subramanya. In that Subramanya textbook, you won't get most of the problems, but you will get more reasoning point of view, derivation point of view, right? Why the clause was given in that way? What is the reason for this limiting values? The reasoning, the limitations was mentioned clearly in Subramanya textbook, whereas in SS Bhavikatti, the reasoning was mentioned in a single line. Reasoning will be mentioned in a single line, right? And moreover, I can say problems were given a lot. So for student friendly is SS Bhavikatti, but if you want and you improve your knowledge, so beyond the out of box, in such case, Subramanya textbook is good. Okay, that SS Bhavikatti is good. Dear SS Bhavikatti is my teacher. Okay, he is good. Yes. I tried SK Doggal but cannot understand. Here SK Doggal is also good, brother. So every textbook is good, but I just want to convey each and every textbook, either SS Bhavikatti sir or Doggal or any other person, maybe Subramanya, any book was written only from standard code of practice. The standard code of practice is IS 800. So everything, either in the form of exemplify was given only from the code of practice only. So if you are good in code of practice, you are able to crack anything, right? Yes. Okay. Is that okay? Right. So let me answer this question, brother. So this is we are in the middle of this answering this question. Na? So come this is shear mode. In bearing, how we can work out the rivet value in a single shear? In case of bearing, how we can write permissible bearing stress? The permissible bearing stress is 250 megapascal into bearing area. What is bearing area in working stress method? In working stress method, the bearing area is, I can say, like diameter of the bolt into thickness of the plates which are experiencing bearing stress in one direction. So diameter of the bolt is 21.5 into thickness of the plates which are experiencing bearing stress in one direction. What is the thickness of the plate which are experiencing bearing stress in one direction, brother? Thickness of the plates which are experiencing bearing stress in one direction is 10 millimeter. So if you do in this way, directly this answer is 53.75 kilonewton. This is how we can write for rivet value in single shear. But the question is not that. Please read the question properly. What is the difference in the rivet value in single shear and double shear? This is the rivet. What is the rivet value in single shear? Rivet value in single shear is this much. So rivet value in single shear is 29.04 kilonewton. Similarly, I need to work out rivet value in double shear, right? So what is the rivet value in double shear? Can I work out rivet value in double shear? So in such case also in shear board, double shear will happen instead of two plates. If I had gone for three plates in this way, then the possibility is double shear, na? Then the possibility is double shear here. When I had gone for three plates, in such case, it is 80 into, maybe this is in double shear. In single shear, this is a double shear. 8 into pi by 4 into 21.5 square. How many shear planes are there? Two shear planes are there. So I can say int as 2. This, if I work out, it is 58.08 kilonewton. But in terms of bearing also I need to consider. So coming to the bearing issue, it is bearing permissible stress is 250 into 250 into what I can say, 250 into D into T. Diameter of the bolt is after riveting process is 21.5 into T stands for thickness, summation of minimum thickness of the plates which are experiencing bearing stress in the same direction. So what is the minimum thickness of the plates which are experiencing bearing stress in same direction? If you take one plate, one plate is experiencing bearing stress, the 10 thickness plates are experiencing bearing stress in one direction. Another plates like 10 plus 10 plates are experiencing bearing stress in another direction. Out of these two thicknesses, I need to consider the minimum thickness. The minimum thickness is 10 millimeter. Na? So I need to use here also 10 millimeter. So in such case, this answer is 53.75. Right? Is that okay? Now they are, what is the rivet value? Rivet value for double shear is 53.75. Rivet value in single shear is 29.04. So what is the difference of these two? Can you work out the difference, brother? So difference, can I write that one? 53.75 minus 29.04. In this is in double shear, this is in single shear. What is this difference of this rivet value in single shear and double shear, brother? So the difference, I hope you are able to get this answer as Definitely 24.7 kilonewton. Isn't it or not? What is the where this answer option of 24.7 kilonewton is there, brother? Dear Salu Salima, the option is B for Boston is the correct answer, right now? Is that okay? Salu Salima, right? Yes, this is how we can work out. The question is not just about rivet value. The difference in the rivet value when it is in single share and when it is in double share. That is how they are expecting the question. So can I move to the next problem? Right? Yeah. Moving to the next problem. I hope you are able to see. If tau VF calculated, I hope you are able to see. If tau VF, that is the shearing stress calculated, and sigma TF, that is the tensile stress calculated, is calculated shear and axial tensile stresses respectively in fasteners. Fasteners means maybe bolts or rivets, right? If tau vf e, if tau vf and tau vf and sigma tf is calculated is allowable shearing stress. These are so tau vf and sigma tf is the allowable shear. Allowable in sense these are permissible shear and permissible shear and axial tensile stresses. Then for the safety of the connection, these are in terms of stresses. In terms of stresses, in old code, in old code, condition, I mean, I can say interaction equation condition was given. Interaction equation, interaction equation is given. I had already mentioned you with the help of another nomenclature. So developing shearing stress. The developing shearing stress is tau VF calculated as per the given words. What is the permissible shearing stress? The permissible shearing stress is tau VF. Developing shear stress by developing shear stress by permissible shear stress or allowable shear stress plus developing axial tensile stress by this sigma TF axial tensile stress by uh, I can say allowable axial tensile stress. Allowable axial tensile stress is sigma TF. This value, this combination should be less than or equal to 1.4. This is how you can see in old code means this is in working stress method, which is as per IS 800, I can say 1984 code. The same thing as per, I hope I already mentioned you in our previous slides, the same condition in limit state method. It was given in terms of forces. When it is given in terms of forces, developing shear force by shear strength of the bolt. Maybe I can say VDB, where developing tension force in the bolt by design tensile strength of the bolt, where this value should be less than or equal to 1, right? This is, yes, we had already discussed it. The directly option C, right? Yes, option C is the correct option. Now can you see this question? Which type of joint shows maximum efficiency in case of connection of two plates? In case of connection of two plates, which joint will give maximum efficiency? I hope you know about this efficiency, brother, right? So efficiency is nothing but strength of rupture strength of the plate, or strength of joint, I can say. Strength of joint by strength of solid plate into 100. In which case the strength of the joint is increased. Strength of the joint, again there are two things. Rupture strength of the plate, minimum of two things. One is rupture strength of plate. Second one is number of bolts into bolt value, or number of rivets into rivet value. Out of these two, lesser value I need to consider, right? So strength of the solid plate is always one and same. But in case of lap joint, here in case of single cover butt joint, if you take these two, the efficiency is less. In case of double cover butt joint, I can say more efficiency. Why in case of double cover butt joint more efficiency? In case of double cover butt joint, it is a concentric connection. Is a concentric connection, applied load coincides with the CG of the center of gravity of the fastener group. So whereas here these are not constant, these are eccentric connections, I can say. Somewhat eccentric connection. Eccentric connections. So the load carrying capacity is more for concentric connection than eccentric connection. No? So even in such case, strength of the joint is more in case of double cover but connection. Strength of the joint is more. So I can say option C is the correct option, whereas option A and option B is wrong. Only option C is itself is the correct option. Right? C option is the correct option. Okay. So can I move to the next slide, brother? Please excuse me. Moving to the next slide. Next question, I mean. I hope you are able to see the next question. In which of the following case we avoid ordinary bolted connection? In which of the following case we avoid ordinary bolted connection, brother? We avoid. We don't use. Avoid means we we don't use. Which of the following condition we don't use ordinary bolted connection? I hope you we will avoid. You know the ordinary bolted connection are stopped or not used in case of a permanent structure. Case of a permanent structure, we either we go for riveted connection or we go for welded connection. There is no if there is no dismantling is required. I can say when the structure is subjected to, I can say, frequent earthquake loading. When the structure is subjected to dynamic loading. Dynamic loading, like, what are the example for dynamic loading? Like earthquake loading, wind loading. When these are subject to this type of loadings, in such case we can avoid ordinary bolted connection. When the structures are subjected to earthquake loading and wind loading, in such case which type of bolted connection is preferable? In case of wind loading and earthquake loading, the structure is subjected to fatigue or maybe stress concentration or anything is possible. Especially in such case, I can go for HSFG bolts. So high strength frictional grip bolts are better, but we can avoid these ordinary bolts in this connection. So I can say I don't know which. If I say this is the option, yeah, why this is coming? This option is B is the correct one, right? So can I move to the next question, brother? Vignesh Ram, Shalu, Salima, Navjot Singh. Is that okay? Can I move to the next slide? Moving to the next slide, or maybe next question, right? So here in this next question, IS 800 2007 is based on which method of design? IS 800 2007 is based on limit state method of design. LSM, limit state method of design, right? Whereas IS 800 1984 code is based on working stress method of design, WSM method of design. In working stress method of design, the permissible stresses are less. Permissible stresses are less. Whereas in working stress method of design, permissible stresses are up to the actual extent. Permissible stresses are some bit increased, so which are up to the realistic value, I can say. So the correct option for this case is, what is the correct option, brother? Right, Vignesh Ram, the correct option is D for Detroit. Limit state method is the correct option, right? So can I move to the next question, right? Moving to the next question. I hope you are able to see this one. The unit mass of steel and modulus of elasticity. What is the unit mass of steel and modulus of elasticity as per IS 800 2007? If you refer to IS 800 2007, the density of steel, unit mass means density of steel. Rho S, it is 7850 kg per cubic meter for steel. And the Young's modulus of steel is always one and same, which is 2 into 10 to the power of 5 Newton per millimeter square. Right, 7850 kg per cubic meter and 2 into 10 to the power of 5. And some people, this is for steel. If you are saying for concrete, so for concrete, you can refer IS 456. If you refer to IS 456, generally the density of concrete, it is for, if it is RCC, it is 24 to 25 kilonewton per cubic meter. If it is plain cement concrete PCC, 22 to 24 kilonewton per meter cube. And coming to Young's modulus of concrete, when it is short term Young's modulus is 5000 root FCK. Where this short term Young's modulus, just want to cut. When it is long term Young's modulus, and the short term Young's modulus, I need to, we generally work out this modulus as secant modulus of elasticity. Sir, please do influence line diagram in structural analysis. They are definitely Vignesh Ram. I will definitely do that one. Don't worry. In the next month, I will do, and I will definitely do that one. Or at least in app, definitely I will take that classes, like at least like 10 to 15 classes. I will take. I mean, I will take 15 classes exclusively on influence line diagram in app. So definitely I will do that in the next month. Okay. Now in secant modulus, Young's modulus of long-term Young's modulus. How we can work out this long-term Young's modulus? Short-term Young's modulus of concrete divided by 1 plus theta, where theta stands for creep coefficient. The Young's modulus for concrete for short term and for long term is different. In long term, I need to consider the effect of creep and shrinkage, long term effects also. If I don't consider the effect of creep and shrinkage, then I need to use this short term Young's modulus, which is EC, which is 5000 root FCK. Okay. Right, so this, for this one, in case of steel, if you take, the correct option is, this is A for Amsterdam is the correct option, right? Can I move to the next question? Right. So I hope if you see this question, the minimum thickness of steel plate. So they are expecting the minimum thickness of steel plate, uh, which is directly exposed to weather. The plate is exposed to weather and is not access, and it is not accessible for cleaning and repainting. And it is not accessible for cleaning and repairing. So in such case, what is this minimum thickness of steel plate I can consider? There are three conditions are there, brother, but let me tell you, right? I just want to give a tabular form. This tabular form was directly there in IS 800. uh, if you see, this is serial number. If I say the condition, there are two conditions are there: when it is directly exposed to weather or not, when it is accessible for cleaning and repainting or not, right? So when it is directly exposed to weather or not, and when it is accessible for cleaning and painting, steel is accessible for cleaning and painting or not, then in such case, what is the minimum thickness of the steel plate? So minimum thickness T, minimum thickness T in millimeter. I want to convey. Maybe in the first case, I will say like, sir, when both, in our present case, when it is directly exposed to weather and whether it directly exposed to weather or not, yes. When whether it is accessible for cleaning and painting, it is not accessible to cleaning and painting. So I can say no. When this is the condition, it is 6 millimeters the minimum one. Please be, you need to memorize this one. Please. Especially this type of questions were asking in SSC JE, so you need to memorize. So memorize these limiting values. These are the minimum thickness I need to use generally to take care of durability aspects. And coming to the second one, when when the steel plate is exposed, when the steel plate is not directly exposed to weather, it is not now, so I can say no. When it is not accessible to cleaning, and when it is not directly exposed to weather, when it is not directly exposed to weather and not accessible for cleaning and painting, when it is not accessible to cleaning and painting, then in such case it is 8 millimeter. So here the criticality of severity condition has got increased. So I need to increase the minimum thickness of the plate. Now in some of the conditions, like this is no. When it is not exposed to weather, and when it is not directly exposed to weather condition, but accessible to cleaning and painting, in such case the minimum thickness of the steel plate that I can use is 4 millimeter. So it depends. What is the minimum thickness of the plate that I can use? The minimum thickness of the plate that I can use, or the gusset plate that I can use, it depends on the type of environmental condition, based on which the minimum thickness of the plate will be different, right? It can be 6 millimeter, it can be 8 millimeter, it can be 4 millimeter. So clearly this is so. In this particular case, the option is B. So directly we can keep this 6 millimeter. Is that okay, brother? Vignesh Ram, can I move to the next slide? Maybe Navjot Singh Sidhu. I can say another girl. Another girl is there. What is her name? Uh, Salu Salima. Salu Salima. Yes. Yeah. Okay. Other persons who are on the online. Yeah. Moving to the next question. Okay. I hope you are able to see this. This we had completed the working stress method, code of practice, all the things we had uncovered. If you people are expecting 2 mark questions of GATE, especially, and ESE 2 mark level of questions, I had a completely worked out connections part, completely worked out for you guys in connection part in the same Let's Crack GATE and ESE. In the same channel, Let's Crack GATE and ESE, you just type this name, design of connection, design of simple connections and eccentric connections, design of connections by, to type this name, Venkata Tilak Uppalapati. Maybe just before 2 months I had completed this stuff. This connections part I had taken maybe 20 hours I had completed in the same YouTube channel. So go and refer this one. In that one, I had even completed the 2 mark questions of GATE and all the stuff. So problematic stuff I had clearly covered using limit state method. Problematic theory for limit state method I had completely worked out there. Problematic stuff and theory as per LSM. It was completely worked out there. Go and watch that. Okay, right. Now, if you take, we had came down to tension members. Is that okay? Now in this tension members, now I hope, are you able to see this question? Consider the following statements regarding tensile test diagrams for carbon steels with varying carbon content. So with varying carbon content, okay, as the carbon content is increasing. When carbon content is increasing, then I can say hardness increases. I can say yield strength increases, ultimate strength increases. Simply, I can say strength increases, right? But what is the properties that will get decreased? I can say, but ductility decreases, I can say, and I can say toughness decreases, and the carbon content is increasing. So based on this one, can you pick when ductility is decreasing? I can say elongation before fracture decreases. When ductility is decreased, what is ductility? Ability of a material to get strained more, especially in plastic region. That is termed as ductility. That is after post peak behavior. If the metal is able to deform more in plastic zone, that deformation is taken as ductile deformation. So it is almost called as elongation in plastic zone decreases. This is what is stuff. Now, can you answer this question, brother, based on this theory? Right? As the carbon content decreases, the ultimate strength of the steel decreases. No, the ultimate strength of the steel increases. Fu increases, na? right? The elongation before fracture increases. No, the elongation in plastic zone decreases. Na? So this is also wrong. The ductility of the metal decreases. Yes, the ductility will get decreased. This is correct. So this is right. The ultimate strength increases. Yes, this is also right. The strength parameters, ultimate strength, yield strength, both area of the strength will increase, right? So that is option 3 and 4 are correct. Option 3 and 4 means that I can pick option A. Amsterdam is the correct option. Is that okay, dear Vignesh Ram? Right? Is that okay? Right? Dear Shalu Salima, Navjot Singh, brother, can I move to, yeah, yeah, can I move to the next question? So the effective flange area in tension of a plate girder. What is the effective flange area if you take a plate girder? Maybe the plate girder will be in the form of flange plates and web plates which are connected with the help of rivets or bolts. Let suppose maybe if I had connected with the help of weld, I had connected with the help of weld. If AF is the area of the flange, area of each flange, this is AF. Area of the flange area is AF, right? And AW is the area of the web. AW is the area of the web, right? What is the effective flange area in tension? In tension in the plate. What is the effective flange area in tension? So if you take, because when this flange is acting in association with the web, some part of the web will act in association with the flanges. This is the effective flange area. I can say this hatched portion is the effective flange, and this is effective flange area. It is area of the flange is okay, and this portion, what is this portion of this area of the web? This portion of the area of the web is area of the web by 6. This very area of the web by 6. So I can say effective, if you refer to the code of practice IS 800, so effective flange area for plate girder, plate girder in tension, in tension zone, in flexural tension zone, it is area of the flange plus area of the web by 6. It is the effective area. If you are expecting net area of flange, what is net area of flange? Net area of flange, especially in plate girder, in plate girder, in tension zone, in tension zone, it is area of the flange plus area of the web by 8, right? This is net area. This is the effective area. Now the option is AF plus AW by 6. AF plus AW by 6. Na? This is AF. Let me show AF. This typing. I mean, that the scribbling tool. I mean, it was not clear. Right now, I hope this is correct. Right. So I hope you can see option D for Detroit is the correct option. Okay. So what is the order of elongation which a specimen of mild steel undergoes before fracture? So before fracture, what is the percentage of elongation of mild steel? I hope you know what is the percentage of elongation of mild steel, brother. So the percentage of elongation of mild steel before fracture, I can say percentage of elongation of mild steel. If I want to say the range correctly, then in such case, for mild steel, the percentage of elongation just before fracture is 23 to 35 percentage elongation, higher percentage of elongation. But if for HYSD bars, the percentage of elongation is less. Now, when it is 25 to 30, 25 to 35 percentage, here it is in terms of 0.1 percentage, 1 percentage, 10 percentage, 100 percentage. Suitable option is in terms of 10 percentages only. Na? So I can pick option C. Now, for the same mild steel, you are expecting other properties. What are the other properties for mild steel? So coming to the other properties for mild steel, I can say about the percentage of elongation. Maybe I can say uh, first one is proportionality limit. Maybe here I can proportionality limit. What is till what strength proportionality limit in mild steel will happen at a stress of 190 to 230 megapascal, 220 megapascal. Proportionality limit will exist. Mild steel means Fe 250, na? So yield strength is roughly around 250 megapascal. So, but the linear proportionality limit will stay maybe between 190 to 20 megapascal. And coming to yield strength. So, what is the yield strength limits generally for mild steel? Yield strength limits for mild steel generally it will be between 230 to 250 megapascal. In between, the material will get yielded for mild steel. And coming for mild steel, proportionality limit is over, yield strength is limit is over, and I hope you know ultimate strength. Generally, what is the range for ultimate strength for mild steel? Let me write for ultimate strength. Ultimate strength. What is the ultimate strength of mild steel? It will be roughly around 410. If I want to give a range, it will be the minimum value is 410 and it is maximum value is 530 Newton per millimeter square. It is the ultimate strength range. And coming to fracture strength. Fracture strength range, I hope it will be between. I hope you, if you see the stress strain curve, this will go this up. Is almost just like that, that just equal to this fracture strength is almost equal to the yield strength almost only. So just more than this yield strength, I can just more than this yield strength. So when it is just more than this yield strength, it is 250 megapascal to 300 megapascal or Newton per millimeter. So the option for this one is option C is the correct option. This is the question that is asked, but this is the extra data that we are providing for the mild steel, right? Right. So I hope you can see a plate. Next question. A plate used for connecting two or more structural members. A plate which is used for connecting two or more structural members intersecting each other. And two or more structural members. This is one member. This is second member. This is third member. When three or four members are intersecting at a point, in such case, for joining all these four members, five members, or 10 members, in such case, what is the name of the plate generally we will use? What is the name of the plate generally we will use? Which is the common plate where over which will join all these things here in the form of weld. What is the name of this plate? The name of this plate is nothing but gusset plate. So gusset plate is a plate which is used for connecting two or more structural members intersecting each other, right? Maybe this is one structural member, another structural member, other structure, other structure. All the structural members are meeting. So the common plate which is used to join all these structural members together at a particular point of intersection, that is nothing but gusset plate. So I can say it as gusset plate C, right? There is no base plate. Base plate is the base plate is nothing but a slab base used to transfer load from steel column to concrete foundation. There is no such template, no shoe plates are there, so directly we can say only gusset plate, right? So can I move to the next question, brother? Right, moving to the next question, right? Moving to the next question. So which one of the following stresses is independent of which one of the following stresses is independent of yield stress as permissible stress for steel materials? Which one of the second, which one of the following stress is independent of the yield stress as the permissible stress for structural steel? I just want to convey the permissible stress for structural steel. If you refer to IS 800 1984, nowadays in IS 800 2007, all the stresses are dependent on yield stress, or some of the stresses are dependent on ultimate stress, right? So if you take IS 800 1984 code, that is old code of practice, the permissible values for axial tensile stress, permissible value for axial tensile stress is 0.6 times of F5, which we people call as F5 by 1.67. The overall factor of safety for steel in axial tension is taken as 1.67 there. Coming to coming to bearing stress. The bearing stress, the factor of safety or partial safety factor, the for bearing stress, the permissible bearing stress is taken as 0.75 times of F, the permissible bearing stress that we can use. Coming to maximum shearing stress, the permissible maximum shearing stress as per IS 800 1984, it is 0.4 times of 4.45 times of F. 4 5 times of Fi is the permissible stress of maximum permissible shearing stress as per old code of practice. Coming to the stresses in slab base, coming to the permissible stress in slab base, the permissible stress in slab base, especially as per old code of practice, is 185 megapascal Newton per millimeter square for all types of steel. So here in this option, only the stress in slab base is the one and only correct option as per old code of practice. But even if you come down to new code of practice, in new code of practice, stresses in slab base is taken as F by, in this is old code of practice. In new code of practice, it is Fi by 1.1. We had taken in this. Okay. In new code of practice. In new code of practice, no answer will match with these options, but in case of old code of practice, as per working stress method, we can say this option D is the correct one, right? I hope you understand the difference between old one and new one. These are the values I had written directly for old. If you are expecting for newer ones, directly axial tensile stress, I can say it as Fi by 1.1 as per new code of practice. Coming to maximum shearing stress. Maximum shearing stress is Fu by root 3, permissible shearing stress divided by 1 by factor of safety. Factor of safety can be either 1.25 or 1.5 depending on whether the factor of safety may be 1.25 or 1.5 when it is for different shear elements. When it is for uh, different types of steel, right? So coming to bearing stress, this bearing stress here, bearing stress is a type of crippling stress only, na? So here the factor of safety it is Fi by 1.1 here. How it was considered in new code of practice, right? So can I move to the next slide, brother? Correct option is D. Is that okay? Now here, uh, if an equal area, if equal angle of net area, equal angle of net area A has been attached to the support by means of a lug angle. So what is this lug angle? Let us suppose if this is a gusset plate. This gusset plate, an angle is connected. Example. If the length of the connection is high, if more number of bolts are need to be given here, this is a very high load is coming. Very high axial load is coming. Such case, if I want to introduce more number of bolts, here I need to introduce 30 number of bolts. In such case, the length of the overlap required will be very high. In such case, wastage of the material is also very high. In order to reduce the wastage of the material, in order to reduce the length of the lap, in such case, there is another angle is used, which is in addition to this one. Another type of angle is used. To this angle, if I use bolts, this angle which is used is a lug angle. What is the use of this lug angle, brother? The use of this lug angle is to reduce the length of connection, to reduce the gap length. Generally, I can say. Okay. If allowable stress in tension is F, if F is the allowable stress in tension is F. What is the load carrying capacity of the member? Load carrying capacity of the member is allowable stress in tension F multiplied by net area. Net area is A. So it is F into A. So it is 1 times of F into A, right? Because A is the net area. So in such case, permissible stress into net area. If I want to take it as permissible stress into net area, is 1 times of F into A. So I can say option D itself is the correct. Right. Hi, Annadurai. B. Hi, Annadurai. How are you? Hope you are fine. Yes. Hi, Vignesh Ram. Yes, to reduce the length of the connection. Yes, we use this lag angle. Definitely. So can I move to the next question, brother? Right. Moving to the next question. So I hope you can see the effective length of an angle member in a riveted truss. I hope if you take a riveted truss, you take a riveted, here it's a gusset plate, it's a gusset plate, it's a gusset plate. Here it's a gusset plate, gusset plate, gusset. And when it is a riveted truss, how many rivets generally we will keep at the connection? Generally more than one rivet. Generally more than one rivet, like two rivets or three rivets or maybe four rivets. When it is more than one rivet generally, when it is here also more than one rivet. When the number of rivets here at the end is more than one, like two or more. Here also two or more. In such case, the effective length, the distance between the effective length is rivets is generally like a hinged connection. But when the hinges are connected with the two or more uh, bolts, in such case the effective length is 0.85 times of L when two or more rivets at the connection. When effective length is just one times of L when only single rivet when only single rivet exists at the rivet only exists at the connection. In this case, as they didn't mention anything, generally I can say like generally or practically the number of rivets are maybe two or three, maybe more than one generally. You take entire truss. So in such case, practically I can go for 0.85 times of L, not just simply one times of L. Hariprasad. Hariprasad says, sir, in case of unequal angle. Dear, here they are saying like in an equal angle of net area. In case of either equal angle or in case of unequal angle. The answer is generally in case of any structural element, brother, either equal angle or unequal angle. The answer is permissible stress multiplied by net area. So you should be able to work out the net area. I hope you can work out the net area in terms of angles. Net area we need to work out. I have mentioned the net area itself is A. Either in case of equal angles or in case of unequal angle, this A stands for net area of angle. After the net area is the area after deducting poles, right? Either for equal angle or unequal angle. In such case, it will be one and same, brother. Where A stands for the net area. Clearly, they had clearly mentioned A is the net area. It's not the cross section, right? Is that okay, dear Hari Prasant? Hari Prasant, is that okay? So here in this one, the option is B for Boston is the correct option, right? So can I move to another question, dear Hari Prasad? Next question. Moving to the next question. Right. So the strength of yield strength of the steel is yield strength of the steel is second, let me rub this. Okay, the yield strength of steel is 400 megapascal. Okay, is used in the structure. What is the value of maximum allowable tensile strength? What is the value of maximum allowable tensile strength or permissible tensile strength? So this is as per IS 800 1984. I am asking this question as per IS 800 1984. What is the value of maximum allowable tensile strength? The maximum allowable tensile strength as per working stress method, it is zero point 0.6 times of F5. How we got this one? F5 by what is the factor of safety for structural steel in axial tension? In axial tension, I can take it as 1.67. So in such case, it is 0.66 times of F5. 0.6 times of F5 means 0.6 times of 400, which is 240 megapascal directly. So I can directly pick option A. right? Is that okay? Is that okay? See, most of the questions I am working out by working stress method, because the limit state method I had entirely screwed up in before 2 months. I had completely worked out the entire limit state method with so many problems. With the theory problems, I had completely worked out before 2 months in the same channel. So I am working out mostly the clauses about the working stress method as per old code of practice. Okay, right. So can I move to the next question, right? So moving to the next question. A steel plate is 300 millimeter wide. I hope you are able to. A steel plate, right? A steel plate which is 300 millimeter wide and 10 millimeter thick. Steel plate of width is how much? 300 millimeter width and 10 millimeter thick, and thickness is 10 millimeter. A rivet of nominal diameter. Diameter of the rivet is 18 millimeter. Nominal diameter of the rivet is 18 millimeter. The net sectional area, when the nominal diameter of the rivet is 18 millimeter, what is the diameter of the hole, brother? Diameter of the hole, maybe diameter of the hole, which is D, which is diameter of the rivet after riveting process. Dia of hole is equal to diameter of rivet after riveting process. Diameter of the rivet after riveting process, which is diameter of the nominal diameter of the rivet plus 1.5 millimeter, is 19.5 millimeter. The net sectional area, there is a single hole is there, and there is a single hole is there in this way. There is a single hole is there. What is the net cross sectional area? The net cross sectional area, because there is only one hole, now this is how the net cross sectional area. And how we can work out the net cross sectional area? When the section is vertical, the net cross sectional area is B minus, the width is B minus number of holes multiplied by diameter of the hole. The diameter of the hole is D, so which is D or DH we can write, into thickness of the plate. So width of the plate is 300 minus n. How many holes are there? Only one hole. Only one bolt is there. So only one hole is there directly. So I can write 1 times of diameter of the hole. Diameter of the hole is 19.5 into thickness of the plate. What is the thickness of the plate, brother? Thickness of the plate is 10 millimeter thick. So into thick. So if you take, this is how the cross section will be generally, I can. This itself, this hatched portion itself is the effective area, right? Because there is a hole is there, and the hatched portion is the effective area or net area. So this diameter is how much, brother? This diameter is already 19.5 millimeter. Like that you can understand, right? So which is, what is this answer, brother? Is 2805 millimeter square. People just by looking at this one, they will write the nominal diameter of the rivet 18, but you should not write the nominal diameter of the rivet. Here you need to write the value of diameter of the hole. What is the diameter of the hole for a rivet diameter? Nominal diameter of the rivet of 18 millimeter, diameter of the hole is 19.5. So you need to substitute 19.5, not 18. So in such case, the answer is 2805, which is option B. B for Boston is the correct option. Is that okay? Is that okay, Hari Prashant? Right? Yes. So it's sorry, we had already crossed 2 more hours, right? So for today, I think you had a class by 2 p.m. the same channel. So I need to stop the session so that you can take some lunch. So we will tackle the remaining questions or remaining clauses in your next session, right? Tomorrow. Okay. So for today, I'm just stopping the session. Before I end up the session, I just want to convey one thing. There is so much of I can say one thing. There is paid course is already there in Unacademy Learning app. If you want to join that paid course, coming to the fees for plus courses for 12-month subscription. For 12-month subscription, after 10% discount, if you use this code VT10, the cost is 27,225. After 24 months, okay, for 24 months duration of course, for 10% discount, the cost is 39,600. So for I can recommend this 12 months duration subscription course for the students who are in final year. Whereas I can give this 24-month subscription course for the students who are in third year or second year. For any of the course, if you want to get 10% discount from 1 month duration to 1 to 24 months duration, you are bound to use this code VT10. When you are able to use this code VT10, directly 10% discount will come on all the courses in an Academy Plus platform, brother. Don't forget to use this code VT10, right? And if you are able to follow, if you want to follow me using this link, you are able to follow me in an Academy learning app. When you are able to follow me in an Academy learning app, I can say like so much of free content that I had already done in an Academy learning app, you are able to get, and the future coming free video lectures of mine will be notified to you, and you will also get the PDF notes for the lectures that I had already taught. These are the three advantages when you are able to follow me. So don't forget to follow me in an Academy learning app, brother. And every day my class is happening in this Let's Crack Gate ESE Civil YouTube channel. Every day my class is happening by 11 a.m. So for maybe 1.5 hour to 2 hours. So you can come down to my class every day by 11 a.m. except on Sunday. And I just want to convey like Kamlakar sir's Pandey's class. Kamlakar sir Pandey sir class is happening every day by 9 a.m. I can even refer Kamlakar sir's Pandey's class. You can go and watch his lectures also, right? And finally, last but not least, I can conclude like, so please subscribe to our Let's Crack Gate and ESC Civil YouTube channel first, and please press the bell icon also. When you press the bell icon, when you subscribe to our channel, you will not miss even a single video from the channel. So please refer the same channel, please refer our channel to your friends also, so that they will also get benefited, brother. Because this is for free of course, at least they let them also get benefited, right? And please raise a thumbs up. So please raise a like to our videos, please share our videos, make it viral, brother. So please, when you share this video, your friends will also get benefited, there is no doubt at all. And if you want to take the subscription in paid course, especially in an Academy Plus platform, use this code VT10 either for iconic courses or plus courses. You are bound to use this code VT10, then directly 10% discount will directly come to you on all the courses in an Academy Plus platform. And it shows your trust on me, and it will directly connect between you and me, definitely, brother, when you are able to use this code VT10, right? And for you guys, I already started a Telegram group also, and the name of that Telegram group is, channel name is Unacademy underscore Civil Engineer Tilak. If you want to come down to this channel, press the link which is given below, which is Unacademy underscore Civil underscore Engineer underscore Tilak. If you press this link which is given below, it will, you guys will be redirected to my Telegram group. If you want to post any of the questions, you are able to post your doubts directly there, and I will take care of your doubts directly there. Is there any is there Navjot Singh Sidhu is there, is here? Because he has asked me like there are certain doubts are there for Navjot Singh Sidhu. So I told like I will give some 10 minutes or 5 minutes at the end of the session, right? If Navjot Singh Sidhu is there, I will answer his doubts, especially in plate cut. Okay, I think he's not there, he left. Okay, anyway, so let me end the session, brother. Okay, let me end the session for today. Thank you, thank you.